So a very good subscriber recently gave me a bunch of supercapacitors, and these ones happen to be on a little circuit board with a little BMS on them. So basically I can just treat them like a battery, and these little circuits make sure that it doesn't overcharge any individual capacitor, so I don't have to worry about blowing it up. So now I'm really eager to power different things with it. Well, the first thing I thought of was powering a laptop, because I happened to find this little connector that I lost like 6 years ago. So this little connector is actually from the internal battery of my very first laptop. This laptop was made in 1997, before lithium ions really came into the market. So this one uses a nickel metal hydride, meaning that it's not as complicated for charging, because a newer laptop battery pack from like after 1998 or so usually uses 18650 cells, and those have a more complicated computer in them and a complicated thing, whereas this is just 2 wires coming out to the batteries. So I should be able to run this laptop off of at least one of these packs of supercapacitors. This meter is measuring any current going in or out of the capacitor, and then this one is measuring the voltage of the capacitor bank. Just this one's connected up. And never mind this over here, I'm just charging lithium cells for some other projects. Oh, it's going up. 40 milliamps of current. So this is slightly charging it. Most likely this has some setting where if it detects a low voltage, it thinks the battery's dead, so it tries to trickle charge it up. And then whenever it reaches a certain voltage, it should go up really high. So that's kind of cool. I haven't opened this laptop in forever. Let's see if it has any more power go into it. Oh, charging went off whenever I turn it on. So it stopped charging. That's interesting. I actually have a beta version of Windows 2000 on here. It was like one of the only operating systems I could find that would work on it. That would be past Windows 98. Man, I haven't used this laptop in forever. The screen has a very slow refresh rate, so when you move the mouse around, it basically just disappears. It's kind of interesting. It's a very old computer. Chocobo World. Oh, is this a little Tamagotchi thing? Load it. Yes. And it's climbing really slowly, so 18650, you gotta wait. I'm gonna take over this power supply real quick and use it to charge this really fast. There we go. That's going nicely. At a certain point, we should see the current from this go up, because this is not measuring the current from that. This is just only measuring the current from that. So, yeah. Oh shit, look at that. It went up to 1.4 amps. I'll turn that off then. That is going pretty well. Now this thing can take over. Something smells like it's burning. It's probably not the best thing. I know these feel really hot. Oh, that's a little warm, but The best way to see if something's burning is to check with thermal. So this looks okay. Let me just get it in focus here. Yeah, these cells seem to be okay. If I get it out of there, we can see which ones are warmer. That second one seems to be kind of warmer. Unfortunately, all this other stuff like this computer here are changing the contrast. Now we're in focus. Looks like it gets very warm near there. Like around body temperature. Well, at least I don't see any burnt components on here, like anything that's really hot. Oh, that's what it was. This little connection right here was arcing over. Well, at least now I know. I'll keep an eye on that. Oh, open power meter. 80% charging. Okay, that's cool. I've never actually plugged a working battery into this, so I've never seen this. That's pretty cool. So when I disconnect the power on this, it should keep running. Look at that. We can see the voltage dropping. It's saying power source the battery, 100%. That's pretty cool. And I'm kind of wondering if that will change. Like, how smart is that measurement? Because it seems to just be jumping from like 80 to 100, so it might only have increments of 20%. I'm kind of curious at what voltage this turns off. But it definitely is running, it's just it doesn't run very long, that's the issue. Yeah, that goes down pretty quick. I'm not thinking laptops are designed to handle batteries that go down so quickly, so the interval between checking the battery voltage might be longer than this will actually last. I think this thing cuts out at 8.5 volts, just from my previous experiments with this, because I've experimented a ton with this laptop, powering it off solar and whatnot. It was really fun. It is really fun too. Oh. Battery just died. Or at least it died off the battery, so I guess my estimate of when it would die was wrong. See about plugging it back in. Okay. Oh, interesting. Well, I guess I can just plug it. That was odd. So I calculate that one of these capacitors should have about 2.2 watt hours of energy stored in it whenever it's at 2.7 volts. Let's say this can only handle, like it can only use the later quarter of it. Well, then this would have like 5.5 or 6 or so watt hours, or 0.6 watt hours, I mean. So then we have 6 together. That would be 3.6. So we have 3.6 watt hours of power right here. It's kind of interesting. Yeah, seems like it cuts off at that voltage. I'm curious if at a certain voltage it'll start charging it again. So I guess I'll just pull some power from it to speed this up. Let's see if it gets below 10, will it start charging it? No. Okay, that's interesting. If I disconnect it and reconnect it, I wonder if it will. So will I disconnect and reconnect? Maybe it goes by the actual connection of that little connector, because there's a little thermocouple on here. So we disconnect it. Ah, it looks like that's it. So it did. The little icon on the taskbar did go away. So now I can just pop this back on, and it might start charging it again. Or not. Oh, yeah, it is. It is charging it. Well then. So it's cut off at the same voltage as before. I'll unplug the power. We'll see how long it takes to go down this time. The amperage really is spiking up and down a good deal. I'm hearing something making a sound. It sounds almost like the CD-ROM drive running, but that's odd. It's like a beeping sound. Maybe that is a voltage alarm. Battery meter saying 100%. So let's see if it cuts off at 950. At 9.5, I mean. I'll keep the cursor active to make sure it's not going into some weird sleep mode. I could have sworn this used to go down to 8.5 volts though. Okay. Well, it's definitely lower than last time. Okay, so that was, let's say 9.3 volts. So now I'm adding a bunch more supercapacitors. I'm bringing them up to charge using this old lamp to bridge the gap, so this one is now charging this other pack and it should be bringing it online. This one will get dimmer as the voltage difference equalizes. The laptop should start charging it eventually, I hope. Now I can just find some more connectors and start connecting these together. So I have 5 supercapacitor banks connected up, and this is taking a long time to charge because it's such a low voltage. And so I've tagged this little radio, so it's connected up where the computer is. So along with the computer charging it, I can turn this, and I can be charging the battery. I mean the capacitor. Blah. Ugh. This is not meant to be worked that much. Oh, fuck. This is a really big capacitor bank. It's taking a lot longer to charge. Oh, I just thought of a way I can charge this. So, I can use the connectors from my capacitor tester. I can connect these into my power supply, since it still has a banana plug on the front. Then I can charge it this way. Ooh, nice. 3.5 volts. Okay. I think I can get behind that. Oh, interesting. So evidently one of the last things I modeled on this computer, because this used to be my 3D modeling computer, even with all its 1 megabytes of video memory and 80 megabytes of RAM. But I was able to make some nice models like this. This is an exact model, or almost exact model, of my Atari race driving arcade machine. At least the outer casing of it. I spent like 2 hours making that on this. It is a bit slow, but it's not too bad. I think it's pretty cool to be able to make a like 3 models on a Pentium 150. Especially with Blender. Unfortunately, the newer Blender 2.5 doesn't really work too well on this computer, so I have to stick to 2.49, which seems really old now, because it is really old. Let's see if I can render it. I think this is going to take a while. Took 3.5 minutes to render that. That actually wasn't that bad for such an old computer. 10 volts, that's not too bad. Pretty soon it should be at the maximum voltage. It is slowly ticking up. Yep, just really slowly. But that means it should also slowly tick down, so that's good. We should maybe get at least a couple minutes of power from this. Oh, it just switched over. So I figure I'll unplug it. So now we're running off of the battery. So that's the current, that's the voltage. You already know that though. I feel like playing a game, because we're going to have a good amount of time, hopefully. Maybe. Well, either way, let's see how much of a level I can get through on 1602. This game can take like hours to play. It's a really fun game too. Basically, it's a civilization building game. To skip all the setup procedure, I'm just gonna start a game that I had already played. Oops.
access to building materials from your inhabitants.
That voltage is really going down a lot quicker than I expected. Okay. Well, I guess I can't handle actually doing much. Well, I'm kind of bored of this. So, let's change objectives and just light up this lamp, you know? Why not? Sounds fun to me. Hooked up through the multimeter so we can see how many amps it's pulling. God, this setup sure is a fire hazard. It's like a rat's nest of wires and supercapacitors. That's why I want to discharge it before I undo any of this, because I don't want to have any high current sparking. All powered by supercapacitors. This should last a couple minutes, and especially a lot longer than the laptop, because this is a, I guess what would the term be, a passive load? A passive analog load? I don't know. But yeah, basically this is just going to, it'll slowly get dimmer, it's not just going to turn off. I really like that light. I'm wanting to put this as the rear headlight, or I guess the real tail light, that's the right word. The rear tail light on my new steampunk e-bike. One way to get more power out of this, of course, is to hook up a step-up transformer, and so you can most likely get 4 times the battery life. Also, charging this all the way up to 13 volts, because this is, of course, only charging it to 11.8 or 11.9 or so. So that would help also, because I'm really only using up 1.5 volts, which if I could use up a wider range of power from this, then this laptop could last a lot longer. But the thing is, though, we're still only talking about a small amount of time. I wanted to do quite a few projects for this with this, though, because even though these don't have high capacity, they are still very interesting, and they're very useful, and they have their own specific niceties, like high current and low weight and whatever. Also, not having to worry about, like, because I think they have more reliability than batteries, although they do wear out, but, you know, I think they'll last longer, and so I could have them somewhere without having to worry about the batteries slowly losing charge. I don't know, I mean, I think I've heard supercapacitors are actually different, so they actually do lose power, lose capacity like a battery, they're not as rugged as other, like, electrolytic capacitors and whatnot. I could be talking totally wrong, though. But yeah, maybe sometime in the future I'll see about making a second video. But I don't know. I kind of feel like doing other stuff. Like, for instance, it'd be kind of interesting to take one of these and modify a little RC motor to be a generator and a motor on an electric bicycle. It'll be a friction drive on the back wheel, or front wheel, whichever one works for you. And so it'll be a regenerative braking system. It won't be actually like electric power, but it will be a regenerative braking system to where whenever you stop, it can pull a load from the little generator and it can charge this up while it slows you down. And then whenever you want to go again, you can discharge this energy back into the little generator and act like a motor, and it helps push you just a little bit. That'd be kind of interesting. So you could have, like, just enough power in one of these to get you going at a light. So that'd be actually kind of neat to save your momentum, because when you're on a bicycle, it's really, you don't want to stop, because it's like, it's kind of hard just going again, if that makes sense. Also some other projects and stuff like that. So many cool things to do with this. So that's pretty much it. I hope you guys enjoyed this video about supercapacitors, and I'm definitely having a lot of fun with them. They're very cool. I found out one of these is actually bad. There actually is a bad cell. I marked it, so I can take that one out, and I can see about swapping it out with a better one or something. I might even do an autopsy on that one. That'd be kind of neat. Well, I hope you guys enjoyed this video, and thank you very much for watching. See ya!